How to find percentage and absolute uncertainties. An absolute uncertainty is a measure of the inaccuracy in a measurement, and it's presented as a value that is not relative to the average value of the measurement. In OCR Physics A, you should always put uncertainties to the same number as significant figures as any other uncertainties in the question. Most commonly, this means putting the uncertainty to one significant figure. Even if no other uncertainties are given, you should always try to put it as one significant figure, unless there's another uncertainty that's at two or more significant figures. On the other hand, the percentage uncertainty is relative to the average value of the measurement. Both absolute and percentage uncertainty are completely reliant on each other, and you can always determine one using the other. To find the absolute uncertainty from a set of experimental values, as you will often be asked to do, you have to find the mean of the set of values, you then find the range, and the absolute uncertainty is equal to half of the value of the range. In this question, we can quite easily find the mean from the set of values, as we just add them all up together and divide them by 5 to give us a value of 1.872 millimeters. In order to find the range, well, we simply look at the largest and smallest value, and to find half the range, we divide that by 2, and that will always give you the absolute uncertainty. The reason that calculating the mean is important is that often the value that the uncertainty is compared to. In this question, you're not asked to do that. However, in many variations of this question, you will be asked to find a value along with its uncertainty. To turn an absolute uncertainty into a percentage uncertainty is easy enough. All we have to do is find out what percentage of the proper value the absolute uncertainty would be. In order to do that, we divide the absolute uncertainty by the average measurement that we calculated earlier, and multiply that by 100 in order to get a percentage value. In order to get an absolute uncertainty from a percentage uncertainty, we would have to do the same steps but in reverse. So we'd divide the value by 100 and we would times it by the average measurement. In this case, dividing the absolute uncertainty by the average measurement gives us a value of 0.0107. We multiply that by 100 to get a percentage value, which is equal to 1.07%. And I would always put that as 1%, as since it's not given us a value of uncertainty previously, I'm going to assume that it wants the uncertainty to one significant figure. Although since it is a percentage uncertainty, I would put it as 0 decimal places rather than one significant figure if the value was more around, say, 20%. Now, to move on to the next question, we're going to figure out how to calculate the percentage uncertainty of a value derived from other values. Typically, in these kinds of questions, you will be given an equation, or you will be able to figure out an equation, and you will also be given the percentage uncertainty of several values or quantities in that equation. You will then have to determine either the final percentage uncertainty or perhaps the final absolute uncertainty of the value determined by that equation. So the first thing you want to do is you want to figure out what equation you would use. In this case, it's given. For the second step, you add the absolute uncertainties of any values that are added or subtracted to each other. This isn't relevant, and we're also not given absolute uncertainties. This might be useful in other questions, but it's not relevant here. If you have to do any kind of multiplying or dividing in any question that involves uncertainties, you are going to want to put everything into percentage uncertainties first before you do anything else. Again, that's not relevant here because we're not given absolute uncertainties, we're just given the percentage uncertainties. But in other questions, it's worth remembering. I'm going to break a little from my script here and instead recommend that instead of adding the percentage uncertainty of values that are multiplied together or divided together, you should instead multiply the percentage uncertainty of anything that's put to a power by the value of that power. So in this case, we're going to double the percentage uncertainty of D. Somewhat counterintuitively, this also means halving the percentage uncertainties of any values that are square rooted. Now, we look at the equation and we add the percentage uncertainties of values that are either divided or multiplied by each other. So, to quickly go over that and solve this question. No values are added or subtracted, so there's no need for absolute uncertainties. Now we're going to look at adding the values of percentage uncertainties together. Though first, we are of course going to double the percentage uncertainty of D and make that 2, as D was squared. Firstly, f is multiplied by 4. It might be tempting to multiply f's percentage uncertainty by 4 as well, but we don't do that. We just add percentage uncertainty of f and 4 together, and as 4 is a constant, constants have no uncertainty, and therefore we just stick with the percentage uncertainty of f. Moving on to what f is divided by, we add the percentage uncertainty of epsilon and d squared. Since we know that d squared is equal to double the quantity of d, it goes up from 1 to 2, as we calculated earlier. This means that the final value of the percentage uncertainty of E is 8.5, which is answer D. If you want to try out some questions for yourselves, I've included a link to a document including the test papers in which the percentage uncertainty or uncertainty questions come up.